There are interesting ideas about how the concept of median may be generalized. We shall discuss some of them here. Now, in order to explain, I shall work with just a bivariate data. So you have got some x here and y here, two variables, but the discussion basically generalizes to even three-dimensional or higher dimensional data. Now, here are my data points. I want to find the centralmost point here. So what do I mean by centralmost point? Now here is one idea which is called the method of half space depth. So in this method, I want to find out the depth of any point inside my data. Suppose I give you this particular point. See, this does not have to be a data point. I just give you some point. Then, in order to find the depth, you will try to reach that point using a straight edge. So you have this straight thing. I have just taken it from my daughter. So I just try to go past my data points until that line just touches this point. And I will count how many points I had to cross. Well, if I approach it from this side, I crossed 1 point, 2 point, 3 point, 4 point, 5, 6, 7, 8, 9, 10, 11, and then I could arrive here. If on the other hand, I attack it from this, I attack it from this, 1, 2, 3, and I have arrived at this point. So I could just cross only 3 points and I could arrive here. So I will say that the depth of this point, or rather the half space depth of this point, is only 3. So this is the concept of half space. I am drawing a line. This is my line, and I want to see as the line enters my data cloud and passes through that point, how many points of my data set does it have to cross. So that is the half space data set, as if the half of the space is on this side and half of the space is on that side, hence the term half space depth. For example, the half space depth of this is the least because this is on the periphery. Similarly, the half space depth of this is smaller, but half space depth of this is more because this is deeper inside the data cloud. Now, the half space depth way of defining the median is take any point whose half space depth is the maximum. So in this case, typically it will be any point more or less in this region. Of course, it is not unique. The depth of this point and depth of this point and depth of this point are all the same, and it looks like that will be the maximum possible value. So that is one way of defining median for a multivariate data, in this case a bivariate data. A related concept uses the idea of simplicial depth. So here again we take a point, a candidate point, and try to see whether this is deep enough inside my data. So I have this point. Now how do I define the simplicial depth? What I do is I take 3 points, any 3 points in my data set, and construct the triangle out of them, like this point and this point and this and this. So I get a triangle. And I can say that this point lies inside the triangle. So basically I want to say that this point is at least as deep inside the data as any of these 3. Now I take some other triangle. I take this, this and this. In this case, this does not lie inside this particular triangle. What I shall do is, I shall take all possible such triples and all possible such triangles and count how many triangles cover my candidate point. That number is the simplicial depth of my point. Now I shall take any point whose simplicial depth is the maximum possible for my data set as my median. So that is another way of defining median. Now, if I have to compute it directly by actually drawing all the triangles, that will be very difficult because there are so many triangles. There are clever, efficient algorithms to go about these things, but this is the main concept. So I am trying to first define the concept of depth and then trying to maximize depth according to whatever concept I have chosen, and any point that maximizes it gives me one possible way of defining median for multivariate data.